rectilinear motion. We are going to understand about all those important points that will be related to rectilinear motion. In other words, you can say one dimension. One dimension. Okay, one dimension. One dimension means okay. We will classify this motion into three types. Three types will be 1D motion, 2D motion, 3D motion. In details, I am going to explain all these points, all those topics. Just right now understand this is our topic. This is our chapter, which name is rectilinear motion. Which name is rectilinear motion. Let's start. We will see what kind of topics will be explored in this during this lecture. So answer is we will see concept, then question answer. These two things, concepts and question answers. Questions answers as a practice. Let me start with motion. Remember, motion can be classified into three categories. First will be our 1D dimension, 2D dimension. Third will be 3D dimension. 3D dimension. Try to understand this three type of a dimension. It is saying one dimension means only in one direction. One dimension means in one direction. One direction. Okay. Similar to the two dimension means in two direction. Object is moving in two direction. Object is moving in two axes. Okay. Three dimension means object over here will be moving in three dimension, in three axes. That's it. Three axes. Clear? Two direction. Two means two dimensions, two direction, three dimensions, three axes, one dimension, one direction. Okay. We are observing motion. You can see motion. Motion means a object will be moving. An object will be moving. An object can move in one direction. An object can go in two directions. Whereas an object can move in three dimensions. Okay, all these things can happen, and even it is happening in the world. This is a basic motion. Okay, basic motion. Now next point is rest and motion. Rest and motion. What are you understanding by this given word? Rest means object is in rest. Object is in rest. Motion means object is in motion. Okay. Now when it comes to rest means velocity is 0. When it comes to motion, velocity is something. Okay, it can be uniform, it can be non-uniform. But this velocity will be something. But when it comes to rest, velocity is 0. V will be 0. With respect to time. Time is compulsory for motion. Object is moving, that object will be covering also time. That's why we say there is a relation of moving object with a time. Yeah, because it is not possible. It is not possible without having time that object will be moving. No. Time is compulsory for moving object. Now, let's explain this motion word in more explanation. It says object will display. Moving object, of course, an object will displace. When an object will displace, then it means that object covered a distance with respect to time. Within some time, within this time, that object covered 2 centimeter, 2 meter, 2 kilometer. Okay. Here, of course, when force will be applied, one force will be extra. It can be external force. It can be yes. When external force will be applied on object, and initially object is enraged, what will happen? Object will come into motion. Object will come into motion. Hence, that object is displayed some distance. Clear? Remember, rest and motion, they are relative. They are relative. Relative. They are relative. Means importance. Here we will see importance of having observer. Observer will help us to analyze that is the object in a rest or in a motion. But reference point is compulsory. Again and again, I am repeating it. Reference point or observer. Reference point will be, of course, object, and observer will be who? Observer will be person. Observer can be maybe for some cases observer will be non-living thing. Right now, understand the meaning of this sentence. They are relative. Relative means according to that person, what is the situation of this object according to that object. Means what reference are you taking? What reference? Okay. For example, again we will take an example of a vehicle. In a vehicle, there are two persons. One person is driving the vehicle, and second person is sitting in the vehicle. What will happen? Through this example, you will understand that the rest and the motion are related. Look, person who is not driving the vehicle, according to that person, driver will be in rest. According to person who is not driving, so driver person will be in rest. But there is a third person who is standing on the road. According to that C person, driver will be in motion. Are you observing? Just we changed reference. Just we changed observer. All things has changed. It happened because of observer. Okay. Remember, an object will be moving, but according to other observer, that object will be in rest. According to another person, according to another object. Yeah, we know that the object is moving. For example, as I told you right now, with an example of a vehicle in which there were two person. One person was driving the vehicle. So driver person was in a rest according to B person. But according to C person, both are B and A both are moving. Reference or observer will decide is an object in a rest or motion. So there is a no importance of absolute for rest and for motion. Absolute. Okay. A lot of time we will see this relative word. Relative word. From here we need to understand three things. First is position, position, and second is rest and motion that we have explained, and third is frame of reference. Frame of reference. This rest and motion is crystal clear for us. Position means location of an object. Location of an object. We want when someone asked to you where is what is the address of uh, this place. For example, this is my relative person, so I want to go that place, but I don't know where is uh, where is the exact this location. You will tell yes, just to cover 100-meter distance, 100-meter distance, then there will come a turn, just a turn in the right side, in a right in the right side, just turn right, then cover only 50 meter, and you will see a building. So in that building, just ask to the manager and give your relative person name, then manager will tell you. Okay, that is how we explain address, that is how we tell location of a something. So position is just a word. It is a very simple to understand it. Location of place, a thing, person, okay, anything. uh, but brother, there is a link of a friends of a reference with position. We will tell anything, we will tell location of anything. It will be possible when we will take a reference, a frame of a reference or observer. Okay, so we took what this turn can be or choke can be our frame of a reference. Choke can be yeah, reference point. Without a reference point, yeah, it is very difficult to explain any location of anything. Okay, so having a reference point will help us a lot of okay. Reference, this reference is also, it can be object, it can be non-living thing, it can be living thing, it doesn't matter. Okay, whatever we are taking as a reference point, it will be valid. And we take a frame of a reference. Why? So that we can tell position of anything. During this lecture we will see position of a point, position of a particle, position of a vehicle, position of an object. Okay, so during this lecture again I am telling you our reference point, mostly our reference point will be origin. Origin means 0, 0.0, 0.0, comma 0, not point but 0, 0, 0. Okay, reference point. So this origin will be reference point for Cartesian plane. Right? These three things are crystal clear for you. Now let's move over towards the topic. First topic. For reference, for this, if nothing is a reference, okay, by the question reference is not given, then you can consider ground as a reference. Ground as a reference. Clear? If nothing, this reference is not given by the equation, then we will be able to consider ground as a reference point. But equation is not providing reference point yet. Okay, so this it is a reference point which is with respect to position. with respect to position. Now let's move towards will be what distance. You know this is a actual path, yeah, actual path, actual length. It is our scalar quantity. This is our scalar quantity. A scalar quantity. Actual path means we are taking all the lengths uh, that was covered by by an object. That is known as the actual length. As scalar quantity, this distance is a quantity, but we consider it as a scalar quantity. Why? Reason is it does not provide a direction. That's all. It does not provide direction. Next we have can't be negative. Can't be negative. Can't be negative means it can be zero. It would be positive, but never ever it will be negative. Yeah, when it comes to displacement can be negative, can be positive, can be zero. Reason is displacement has this displacement provides a direction. That's why. But it is not going to provide direction. That's why we don't take a negative for this distance. Okay, distance will be always a positive. Positive. Okay. Next point. Next point. Unit is a meter. Next we have okay. This is enough for a distance. For a distance. Look at over here. Person B. Try to understand this three section. There are three persons. Let's consider these three persons as a action person, real person. So person A, here B is equal to zero means it is telling you that person A is not moving. This is what you are understanding by this given B is equal to zero. Person is not moving at all. Okay. Now over here person B is given as a moving means velocity. It does not have a zero. It does not have zero. This person B does not have a zero. Means it is moving. Yeah. With some velocity. Whereas person C will be accelerating. Means uh, this with some velocity it will be taking it will be covering too much distance. We will see this. We will understand this person C as a acceleration part in later. But right now, just understand whenever V is equal to zero, it means object is not moving at all. V is something, it means object is moving with some velocity. We will see this part later. This was B is in motion. Now next, let me guys think. Now we have displacement. Displacement. we don't care about the actual path when it comes to displacement. Only we will take a straight line. For example, this person A, and this is a home of a person B. Now there is a road like this. There is a road like this. Not road but straight. Straight. Okay. Person. This person A wants to. This person A wants to reach over here. He wants to go over here. Suppose he will cover this straight. Yeah. This is known as actual path. Actual path, where a person will go through this straight. But when it comes to displacement, we don't care about this actual path. Only we care this straight line. This is straight line. Okay, it will not be our actual path. We are saying that what is the shortest path? Okay, shortest path, shortest distance. This is our shortest distance. From this you can understand displacement can be less than than distance. Yeah, it can happen. Even this is happening over here. Now distance will be equal to displacement. How? Well, let's just say this is also our actual path. It is a straight. This is also actual path. So what do you think? He will cover 5 kilometer. Okay, let's just say 5 kilometer. So displacement and distance. This 5 kilometers for both the displacement and distance. So 5 kilometer distance, 5 kilometer displacement, both are equal. So this is the truth that the distance will be equal to displacement. But remember, displacement is not going to be, displacement will not be greater than distance always, forever. Clear? Displacement will not be greater than distance. Here you can see this is the shortest, but here distance is greater than displacement. These three things will happen. It is the truth, universal truth. This was for displacement and distance. We have seen a definition of a displacement. Now let's see some points to explain this displacement in more details. So second point is vector quantity. This is a vector quantity. Means we know displacement is quantity, but when it comes to vector, it means displacement provides a direction. What direction? Direction is compulsory for displacement. Now, next. This will be our initial. This will be known as initial point, initial object, initial position. Okay. This will be known as a final point or final position. We consider like this for displacement. Or so how to define this in one sentence? Displacement. How to define? I would say this is it is a shortest distance between initial point to final point. That's it. Having a direction. Clear? That's it. It is enough for displacement. This is enough for dis displacement. Displacement. Now there is this part. This part. Displacement. Displacement vector. Vector. What will be displacement vector in terms of a position vector? Let me draw a figure of a vector so that we can understand it in more details. We know vector is nothing but there would be three axes I cap, j cap, k cap. This is x, y, z. In the language of a vector, we consider this x as a I cap, this y as a j cap. Okay, this j as a k cap. Clear? This is our reference point, which is known as origin, 0, 0, 0. Okay. Let's say there is a body over here. There is a body. Name of this body is A. And there is another body. It's not another, but just it is placed over here with some distance. Initial point is A and final point is a B. Final point is a B. Okay. When it comes to coordinate, we represent this coordinate of any point like this: x1, y1, z1, and over here this x2, y2, z2. Okay, that is how we represent coordinates of any body. Now when it comes to position vector, this is vector which we will take a body from reference point. So over here reference point is origin, this origin. Okay, you can consider this you can denote this position vector as a r vector like this. So this is our r1 vector. Again, there this is placed over here. So for this our position vector would be r2. How much it displaced? This much. How much? A to B. So where is the position vector? This r1 is a position vector. We take this from we take it from a reference point till the object, as you can see over here. Position vector. Okay. So displacement of vector in the terms of vector would be position vector. This is our displacement of AB. Clear? Now according to triangle law of vector addition, vector addition. You can see it is forming a triangle with not this is not a right triangle, but yeah, it has a this is a triangle. This one side, this another side, and this is third side. This is third side. Coordinates of A is x1, y1, z1. Coordinates of B is B are x2, y2, z2. Okay. Triangle of vector addition says uh, two sum of two sides will be equal to third side when it comes to right angle. When it comes to right angle. So can't we say that this is forming a right angle? Yeah, you can say. Because of this AB is perpendicular to OB, that's all. So our R1 will be x1 I cap plus y1 j cap plus z1 k cap. That is how we write any position vector in the terms of this is a it's not our displacement vector, okay? Just we wrote a position vector R1. This R1. Same we will write for this R2. R2 will be x2 I cap plus y2 j cap plus z2 k cap. That is how we will write position vector. Remember, brother, here we took this two axis. We didn't take this third axis. Okay, so it doesn't mean we can't take third axis. No, we can take also third axis. But right now we just took this two axis, two dimension. Finally, we wrote two position vector R1, R2. When it comes to this displacement A to B, so according to what point, what particle you are going to define displacement. So according to this A, what is the location of this B according to A? You can also find according to B location of A. Location of A. It is all about the reference point right now. So over here, this R1 plus AB will be equal to R2. Why? Reason is we have a right angle triangle. R1 is equal to this R1 plus AB. R1 plus AB. R1 plus AB will be equal to R2. R2 we are considering this R2 as a hypotenuse side. From this equation you can also write when it comes to just we want to get this AB which is the displacement of this body. So to calculate, of course, this will come over here R1 minus R2 and minus AB minus AB. Can't you write like this? R2 minus R1 is equal to AB. R2 minus R1. It means we are subtracting this R2 from R1. R2 minus R1. We will get this displacement. And we know that displacement is calculated like this: R2 minus R1. R2 minus R1. R2 minus R1. Okay. So finally, remember this point. R2 minus R1, where R2 is our hypotenuse side. So finally, in the term of vector, we can write this AB as a x2 minus x1. x2. From here we will take x2 minus x1, y2 minus y1, z2 minus z1. So x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus j1 k cap. This we wrote this in the language of a vector. In the language of a vector, where here this I cap, j cap, k cap is representing. It is representing that this is a vector. It is written into vector form. Vector form. Just we will subtract to calculate this thing according to this person. According to this a person, we want to get location of a b person. So of course we will subtract this x2 minus x1, y2 minus y1, z2 minus z1. We will get displacement of a b vector. A b vector. I hope you have got it. Now let's take a question. Now it's a time to take question based on our concept that we have understood. That we have understood. First question is find out his displacement at the end of 2 minutes 20 seconds. This is our computation. After reading this, we will have to bring our exact answer for this question. So first step is to reduce, then analyze, and what is it asking? Found out that thing. Let's read this together. Athlete is a person who completes one round of a circle track. This is, let's say we have this circle. A person who is running on the circumference of the circle, he completes one round. How much? One round. Which truck radius are let's say this is the radius r, okay, r, in 40 seconds. In 40 seconds he completed how much round? One round. Radius is r, is not given. This is not given. Find out is a displacement at the end of 2 minutes 20 seconds. It is asking this 2 minute 20 second. In this time, how much round will he complete? How much round? Simple, you can say 40 second and 40 this one round. Okay, this one round 40, then again 40 80 2 80 second 3 140 second. So just we will convert this to 2 minute of 20 second into second. So it will be 60 60 120 140 second 140 second. So right now we have 120 second in three round. So 20 more, we want 20 more second. So can we say he will complete 3.5, means 3 round and one half circle. One half circle 2 minute 20 second, this much round. 3.5 is the answer for this question. Find out is the displacement at the end. Okay, at the end, from the initial till the end. 3.5 is the number of round. After 3.5, the circle athlete will reach from one point of the diameter to another point. So displacement will be our 2r. Displacement will be our 2r. How? You can see. He will start from here like this, one round, then second circle, then third circle, and half. So half he will come over here. So it is showing a diameter. Either you can say D or 2R. Both are equal. D is equal to 2R. So here displacement would be our 2R. But when it comes to distance will be something else. This one, but not R. We will take this distance into pi. This is for you. Whatever was question asking, we have found out. Now next question is a particle start moving from point A and reaches at point B along a semicircular then found out distance and displacement. Try to understand this statement. A particle. Right now we have a particle. In the previous question we had a person. A particle will start moving from point A to point B. From point A and he reaches at point B along a semicircular path. Semicircular means this half. This half is considered as a semicircular path. Then found out like this. This is our semicircular. It is considered as a semicircular path. Clear, brother? Semicircular path. Semi means a half of the circle, of the full circle. So path till here we are crystal clear, but remember this we are going to consider this point as a point. This will be our P point. This is the center, which is the O. So find out the distance and displacement. Both things we have to calculate. We have to find distance as well as the displacement. Displacement. Look at over here. He started particle started from here and he reached over here. So of course distance this state will be our displacement. Actual path is this a curved line, but this straight line is for displacement. So displacement is going to again to this one earth and this is second earth will be equal to 2 earth. Now this curved line is the actual path which is for distance. So for distance, can you say 2 pi r? 2 pi r? No. No, of course. 2 pi r is for a complete circle. Complete circle. So 2 pi r upon 2. So will be our answer pi r. Pi r is for this semicircle. We have calculated this pi r, which is a distance from A to P. This is a curved distance. Pi r. Okay, pi r will be our exact answer. Pi r. Now next question. Next question. Next is which is a little bit different, but not too much different. This one. Then figure is given by the equation. So don't need to worry about figure. This is our complete figure. Try to understand this statement which is in front of you. If you are not able to see this thing, okay, don't worry. I will aspect this thing. When particle moves from A to B, as you can see over here, this is a particle and it moved from here to till here. Then find out this displacement, okay, which is a curve. Now this is a arc. So arc is equal to theta upon r, theta upon L. There is a formula, okay, we will see that formula. Right now, just understand AB, which is the arc, is this a displacement. Distance of a AB arc is what? AB arc is what? Okay, we can also find this displacement state. But remember, AB arc is not a displacement. This is the actual path. AB is our displacement. AB is our displacement. Okay. Did you get an twist? Here AB is this state is a displacement, and AB arc will be our. AB is also considered. This state is also considered as a chord. Am I correct? Chord. So over here, distance. For a distance, or we can say arc. We can say arc. Arc is nothing but this arc. We are calculating this part. So this theta multiple r will be equal to arc. This theta multiple r will be equal to angle multiple radius will be equal to arc, or a yeah, I have written over here arc. So theta into r. To calculate theta, you will do like that. Theta. So L upon r. We can consider this as a L. So L will be equal to uh, not L. Yeah, L will be equal to theta into r. Okay, theta into r. But when it comes to theta, then L upon r. This will happen. L upon r. Okay. To calculate a radius, so L will be as it, theta will go downward. These two things came from here. Okay, to calculate theta, you can write this like that, L upon r. To calculate a radius, L upon theta. To calculate L, theta into multiple r. So what is the theta and what is the radius? Will give you length, arc. But right now, just this question asked only displacement, not a distance. Okay. So if you want to calculate a distance, you can go through this formula, which is L is equal to theta, where L is the arc. Okay. But right now, we want the displacement. So OA, this OA is equal to, we already know this OA is equal to radius. This OB is equal to radius. But brother, in the language of vector, we don't have we are not taking this r as a direction. We want only magnitude. Okay, only magnitude as a radius. So tell me, this is equal to this. So of course we have the a isoscale triangle whose two sides are equal. You can write AB is equal to OB minus OA. OB is our radius, OA is also radius. AB, we took it as a AB. So to calculate this, so OB is where? This OB minus OA is equal to AB. But remember, we, we are taking this OB, OA, these both things are in mode. Here and over here you can see all these those two things are in mode. That's why we will apply over here magnitude sign. So formula will be our AB is equal to R square plus R square, again R square, minus 2R square cos theta. This is our formula. Cos theta, this is our formula. R square, this is 1R and this is second R, minus 2AB cos theta. According to triangle law of vector addition, we applied this formula where this is a magnitude of a first radius and this is a magnitude of another radius. Here this became 2R square because 2 is a 2 came from formula, and here we have a 2R. So R multiple R will become R square. Cos theta is for angle, for rotation part. Okay, for rotation part. There is a derivation behind this formula, but right now our focus is not on derivation of this formula. Now just you can substitute a value of R, a value of each variable. Here over here you can see there is a common thing in this. There is a common thing, which is this will become 2R square. 1 minus cos theta. 2R square minus 2R square, where 2R square is common. Yes, 2R square is a common. Again. One more step I would like to write over here. 2R square minus 2R square cos theta. Both will not curl to each other, not at all. So here 2R square is a common. 2R square 1 minus cos theta. 1 minus cos theta will be equal to AB. Now 1 minus cos theta is equal to, it is equal to 1 plus R square. Over here 2R square, 1 will be as it. Cos theta can be written as minus 1 plus a sin square theta upon 2. You can see this 1 plus 1 minus 1 will come to each other. We will get only sin square theta by 2. 2R square 2R square into sin square theta by 2. 2 to the power, this will become 4. This term here a square will go over here. This square is cutting this root. We got over 2R and sin theta upon 2. 2R sin theta upon 2. This 2 went because of this root. So finally we get this equation, which is for AB displacement. AB is equal to 2R, this 2R into sin theta upon 2. Just you will have to take R as a value. Let's say this R is a 5 and this R is a 5. Theta is how much? 30. Let's say 30. Now over here you can write, you can use this formula. Okay. So 2 multiple R is over here 5, then multiple sin 30 upon 2. Not 30 but 60. Let's say 60. So this will cut 30. 2 5s are 10. Sin value of a sin 30 will be 1 upon 2. 1 upon 2. So finally we got a 5. 5 is the displacement of AB. This 5 became as a displacement of AB. That is how we can apply this formula to calculate the displacement of any body. Clear? Any body. How did it come? Just we saw this two, there were two R, but we can't say that OA is equal to OB. No, it is not valid for this. So vector AB will be equal to OB minus OA. Here we know AB will be equal to AB will be equal to R square plus R square minus 2R square cos theta. From here just we simplify this. After simplify this this things we got this equation. Now here our work is to substitute value of a variable. Variable is R, and we will have to substitute the value of a angle sin theta upon sin theta upon 2. Next question. Next question is